Okay, we're going to pick up with lesson 10.5 again using a distributive property. And like I said yesterday, it's kind of a misleading title. We're actually today going to use a distributive property, but we're going to be factoring by grouping. And factoring by grouping is just a different way to use distributive property, but it is just that. We're using distributive property in reverse. It's just going to take um, a little bit more to do it than it did yesterday. All right, so let's take a look at what they mean by factor by grouping. All right, so number one, factor by grouping. We can only use factor by grouping when the polynomial has four or more terms. Okay, so it's got to have at least four terms. And today you're going to work just with polynomials that have four terms. Okay, and um, what we're going to do is we're going to group two sets of two terms, and then we're going to try to factor those two separately to see if it leads us to a common factor between the two. All right, that's all very abstract to kind of say it to you like that. But when you see some examples, you're going to understand what I'm talking about. Okay, so our factoring process by using grouping, number one, these conditions have to be met. There's got to be four terms or more, like I said. You can't do it with three terms. You can't do it with two terms. It's got to be at least four. Okay, the terms have to have common factors that can be grouped together. And then once we've factored each of those two sets, they have to lead us to another common binomial factor shared between the two different groups. Okay, so again, it's kind of very abstract. We're going to go step by step in this process, and hopefully you see it and understand it by the way I'm trying to use the animations here on this program. Okay, so the first thing we're going to do is this is really kind of like the finishing step that you would do to factor by grouping. Okay, so what I want you to see here is this is really a binomial here with two terms. This is a product, so that's my first term. This is a product, that's my second term. Okay, now looking at these two products, this first one and the second one, what do they have in common? Well, they have this binomial w plus 9 in common. You know, it's 2w squared times the quantity w plus 9 plus 3 times the quantity w plus 9. So they have a w plus 9 in common. What we're going to do first is we're actually going to factor that out. We're going to take that out of each of those and put it in front of a parenthesis. And then what we're going to put inside this second parenthesis is what remains after I factor out the w plus 9. So inside the second parenthesis is what remains after I factor out the common binomial to each. Okay, so let's do another one. Okay, I'm going to bring that back just so you can see it. So this, we're going to count this as two terms. This 5v squared times v plus 2, that's my first term. That's a product right there. 7 times v plus 2, that's my second term. That's a product right there. Okay, what do these two have in common? Well, they have the binomial v plus 2 as a product in each of them. So we're going to factor that v plus 2 out. We're going to take the binomial out of both of those and then multiply it by what remains after I factor it out, which is 5v squared minus 7. And that's considered a factored answer. Okay, this was two terms. Now it's one term, this times this. That makes it a single term. Okay, look at the last one here. Okay, it's 4m times the quantity n minus 6 plus 5 times the quantity n minus 6. What do these two have in common? They got n minus 6 in common, a binomial. So we're actually going to factor that binomial out. We're going to take it out. What's left after we factor it out? 4m plus 5. Okay, that's how you factor by grouping. You're going to get two factors, and in these two factors, they're going to have a common binomial that we're going to take out, and then we're going to write what remains in here. Okay, so let's show you how this actually works. And like I said, today you're going to be working with four terms. Okay, so we got 1, 2, 3, 4 terms in the first one, and 1, 2, 3, 4 terms in the second. Okay, and this is going to be our process here. The first thing we want to do is group it. We're going to group the first two together. Y times x plus 7 times y. That's going in the first parentheses. The second parentheses will be 5x plus 35. Okay, so this is factor by grouping. So the first thing we got to do is group and group. Okay, now what you're going to do is take this first group and take out its GCF. What is the common factor between YX and 7Y? Well, you should see they both have a Y in common. That's the GCF. So if I factor a Y out of this first parentheses, it'll give me Y times X plus 7. If I distribute the Y through, I'll get Y times X and 7 times Y, or Y times 7. So this parenthesis is equal to this product. Okay, now look at your second grouping symbol. What can I factor out of these two? Well, number-wise, they're both divided by a 5. They don't have a common variable, so I'm just going to factor a 5 out. And when I take a 5 out of here, of each of these, that would give me 5 times the quantity of X plus 7. All right, so there's my factored, my second grouping factored. Now, the whole objective of this is when I'm done doing that, I have this common binomial. Okay, this is Y times the quantity of X plus 7 plus 5 times the quantity of X plus 7. So what did these two have in common? They got X plus 7 in common. So I'm going to take that out. When I take that out, what am I left with? Y plus 5, that goes in the second parentheses. Now, let me just show you, if you were to take your answer here and FOIL it, X times Y is XY, YX. Okay, X times 5 is 5X. 7 times Y is 7Y. And 7 times 5 is 35. Okay, so if you FOIL this, you get the same 4 terms you had to start with. That means my original is equal to this. So these two binomials multiplied together equal the original 4 terms that I had here. Okay, so that's how we do the factor by grouping. Take a look at this second one here. Okay, so as you look at the second one, we always start by grouping the first two and grouping the second two. So I'm going to put W plus Y plus 7Y together and 6W plus 42 together. So we got a group to start with. Okay, next, take out the GCF. Well, they don't have any number in common, but they do have a Y in common, so I'm going to pull the Y out. In the second grouping, they have a 6 that we can pull out. So the second group becomes 6 times the quantity of W plus 7. The first grouping gave us Y times the quantity W plus 7. So now we're going to factor this by grouping. So what do they have in common? They both have a binomial W plus 7 that they're multiplied by. So I'm going to factor that out. And when I pull that out, I'm left with Y plus 6. Okay, so there's my final answer right here. This is a product. So now if you FOIL this, W plus Y, WY, W times 6, 6W, 7 times Y, 7Y, 7 times 6, 42. So if you were to FOIL these together, you would get this same answer back. And that's the whole idea of factoring, if you remember, is to take a polynomial and write it as a product of a monomial or a product of two polynomials, in this case, two binomials. Okay, now let's take the same concept, but now what I want you to do is focus in on the grouping symbols, because when you start putting minus signs in here, remember, when a minus sign goes in front of a grouping symbol, you have to subtract both of the items in it. So it impacts the grouping symbol. So let me just show you what we're going to do here. We're still going to group them, the first two together, but I want you to look at the second two when I group it. So the first two is just going to be WX minus 2W. That's as it's written. But notice I have a minus sign in front of this grouping symbol, and it's 5X minus 10. Now, it wasn't minus 10 originally, it was plus 10. But remember, the minus sign of the grouping symbol, you take the opposite of each of the items in here. So the opposite of 5X would give me negative 5X, and the opposite of negative 10 would be plus 10. So this line is equal to this line of work because of the grouping symbol and this minus sign. And what that does, though, is now look inside my parentheses. I have a minus sign in this parentheses and a minus sign here. Okay, that's going to keep my two binomials when I factor the same. All right, let's take a look at my first one here. What can we take out of these two terms? Well, they both have a W, so it's going to be W times x minus 2. What can I take out of these two terms? Well, they both can be divided by a 5, so it's going to be minus 5 times x minus 2. Okay, so I've factored each of my binomials. They have a common binomial now of x minus 2, so I'm going to factor the x minus 2 out. After I factor it out, I'm left with w minus 5. Okay, and just to show you all of our signs worked here, let's just FOIL it. X times w, wx. X times negative 5, negative 5x. Negative 2 times w, negative 2w. Negative 2 times negative 5, positive 10. So if I FOIL this binomial times this binomial, I get my original 4 terms back. That means they're equal to each other, but now it's factored. Okay, same thing here. You got to watch the subtraction signs. Look what happens here. If I group the first two, I'm going to have yv plus 5y. If I put a minus sign in front of this grouping symbol, I can write this as 2v plus 10. Remember, the opposite negative sign in front of a grouping symbol means this would become a negative 2v. That would become a negative 10, which they are originally. But now I can write it as a plus sign in here, which matches this one. Same process. What do they have in common in the first? You factor the first binomial. What do they have in common? These two terms in this grouping symbol. Well, they have y. So I'm going to take the y out here. What did these two? What's the GCF here? It's a 2. Now, as a result of that, I get binomials that are the same. I get these two terms now each have a binomial that's exactly the same. This v plus 5, I'm now going to factor that out. Once I pull it out, I'm left with w minus 2, and that gives me my two binomials that factor this answer into. Okay, just let you look at that a little bit. If you were to FOIL this, first, outside, inside, lasts, you would get this answer back. Okay, but you got to watch those signs. Okay, let's do a couple more here. They're very kind of get redundant after a while. This is the second style of question they kind of give you tonight, and they just use higher exponents. But we don't treat it any different. It's 4 terms, right? Let's group the first two and group the second two. Okay, in the first two here, what's the GCF? Well, they don't have a number that we can pull out. This has x cubed, this has x squared, which means they both have at least an x squared in them. So let's pull an x squared out. That would give me 5x plus 2 in this parenthesis. If you were to distribute x squared through the parenthesis, you'd get this answer back. So these two are equal. What can I factor out of the second parentheses? Well, there's no variable in common, but we could divide both these by a 3. And if I do that, I'd get 5x plus 2. Okay, if I take a 3 out of 15, it's 5. A 3 out of 6 is 2. Okay, if you distribute the 3 through, you get this answer. Okay, this time, the whole objective of factor by grouping was to get these two binomials to be the same. So I'm going to factor those two binomials out. And then what remains after I factor them out goes in the second parenthesis. Okay. Again, if you FOIL this, you will get this back. Okay. Next one, really the same kind of question. Okay. So let's group it up. We'll group the first two terms together, the second two terms together. And now you factor each binomial separately. So what can we take out of this first one? We can take a y squared out. That would leave me with 2y plus 5. What can we factor out here? A 2. And if I take a 2 out of these, I get 2y plus 5. Well, that's the whole objective there, people. Now we have a 2y plus 5 binomial common to each. So I'm going to factor that out. And when I pull that out, what's left is y squared plus 2. There's your binomial times a binomial. So that's a product now, and that equals these original 4 terms. Okay, one more set with these, and again, is watch the subtraction signs. So you start to get minus signs, you got to track them and understand what you're trying to do with them. Okay, I'm going to group the first two, and I'm going to group the second two. Notice what I did, though. I put a minus sign between or in front of this grouping symbol and wrote it as 18x plus 30. Right? Minus 18 is negative 18, minus 30 is negative 30. So by putting the minus sign in from a grouping symbol, I get these back if I was to distribute it through. But now I got a plus sign in my first grouping symbol and a plus sign in my second, and we want those to be the same. Okay, what can we factor out of the first one? X squared. What can we factor out of here? Hopefully you see a 6. When I take an x squared out of my first grouping, I get 3x plus 5. When I take a 6 out of my second grouping, I get 3x plus 5. That's what we want. We want that binomial to be the same so I can factor it out and then write in what remains. Okay. Got another negative situation here. Okay. So now I group the first two together, 4v to the third minus 5v squared. That's my first grouping. My second grouping, I want to have a minus in here. Okay. So if I write a minus sign in front of this grouping symbol, that will make this a negative 8v and a positive 10 when I distribute that negative sign through. So by putting a minus sign here, I get this now to be a negative to match this one. Okay. And it's equal. You know, minus sign in front means you subtract both of those two, which will put you right back here. All right. Factor the first two. What are we going to pull out? A v squared. That would leave us with 4v minus 5. What can we factor out of this one? A 2. That would leave us 4v minus 5. Lo and behold, we get binomials that match perfectly. So we're going to factor those two binomials out. That common binomial gets taken out, and I'm left with v squared minus 2. Okay? So those are the kinds of questions you're going to do tonight. You're going to factor by grouping. Group the first two together, group the second two together, factor the first, factor the second, and when you're done with that, you should get a binomial common that you can take out. Okay? So your homework, it's not too many of those types of questions today, but enough to get you some good practice in, and I will let you get at it.